All right, so we're in the example questions now. So if you haven't seen the first two videos, you might want to go back and take a look at them. You probably could follow from here, but it's not, I can't guarantee anything. There might be some vocabulary you're not aware of. So there are two previous videos that talk about parabolas and their setups. All right, so this problem here says graph the equation y minus 3 squared is equal to negative 8 times the quantity x plus 2. Okay, so just the first thing, just what I notice here is that right there. So what am I talking about? See how the square is on the y value. It's going to be on the y. What this tells me is my graph is either going to look like that or it's going to look like that. It's going to be the non-function version of the parabola. And then the second thing is that this guy right here, because it's negative, because p is less than 0, it tells me that it's going to be this one that we're going to be focusing on. So we're going to be looking at this parabola right here. So once I've established that, now what I want to do is I want to figure out, number one, what is my vertex? So I'm going to take this equation, right, not the equation, I'm going to take the vertex, and I'm going to say my vertex is going to be at negative 2, the opposite of what's being added to the x, and positive 3, the opposite of what is being added to the y. So my vertex is going to be at that point right there. So what I would do is I'd set up my x and my y axis, and then I'd start graphing. So we'll set it up. Here's our x-axis, our y-axis, and then here is our x-axis. It doesn't really matter how accurate you are on these things. Just make sure that you understand that the information you're writing down makes sense. So first, we're going to start with our vertex. Our vertex at negative 2, 3. So we're going to go negative 2, 1, 2, and then up 3 spaces, 1, 2, and 3. So we got our first point right here. This is our vertex. Now, since this graph is p is negative, it's going to be going downward, we know that our focus has to go downward. So what I could do here is I could say, well, negative 8. By the way, p is not negative 8. Negative 8 is what is equal to 4p. So 4p is negative 8, which means p is equal to negative 2. Now the negative, if you're going to be using equations, the negative is extremely important. For me, it's not as important because I'm not going to be using the equations. What I'm going to do is I'm just going to make sure I understand how my graph is going to be set up, how my parabola is set up. Now, I may have said that it's going to go downward. That was a mistake because we did already identify that it's going to the left. So sorry about that. What I'm going to do is now I know that P is going to give me my focus by 2 spaces. So starting at my vertex here, I know that my parabola is going to open up to the left. All right, so I know my parabola is going to open up this way. So I want to make sure my focus is also to the left by a total of 2 spaces. So starting here, I'm going to go 2 spaces, 1, 2, and this is going to give me my focus. So what did I do? Well, I took the negative 2 and I essentially added it to the x value. So I now can say that my focus is located at negative 4, 3 by just taking the p, adding it to over there. So if you wanted to use the equation, it's going to be h plus the p, and that's what's going to give me my focus. Next, I'm going to graph my directrix. So instead of going from the vertex 2 spaces to the left, I'm going to go 2 spaces to the right. So if I go 2 spaces to the right, that gives me a directrix that's perfectly on our y-axis. So my directrix is right here. Now, once again, remember, the directrix and the focus are actually not parts of the graph. They're just parts that are going to help us understand they help define the graph for us. All right, so I'm going to write down my directrix is equal, sorry if I spelled that wrong, my directrix is equal to the equation x equals 0. Essentially, he's going negative 2, the h, minus negative 2, which is negative 2 plus 2, or x equals 0, and that gives us our equation right there. Next, I'm going to find my lattice rectum. Now, my p was 2, so my lattice rectum is going to be 4 spaces above and 4 spaces below the focus. So I'm going to go from here 4 spaces up, 1, 2, 3, 4, which gives me this point, and then 4 spaces below. So 1, 2, 3, and 4 right here. So these give me my 2 lattice rectum points. So if you wanted to, you can write them down. So lattice rectum, rather than identifying as LR1 and LR2, I'll just say lattice rectum and then identify the points. So the points for my lattice rectum are 4 above the focus. So going 4 spaces above the focus will give me negative 4, 7, and then 4 spaces below the focus, which will give me negative 4, negative 1. And then finally, graphing out our parabola. So connecting the lattice rectum to the vertex to the other lattice rectum, and then extending on the other side. And this right here, sorry for the goofy swerve there, and this right here is our first example, how to graph it. Now remember, how did I know it was going to go left to right? It's because the y was being squared right here, and I knew it was going to the left rather than the right because the p was negative. The last thing you'll notice is that the length of the lattice rectum, okay, so the length of the lattice rectum comes out to a total of 8 spaces. And that's important to us because it's usually, or I should say it's always, the absolute value of the 4p. So the lattice rectum is always going to be equal to your 4p if you took the absolute value of it. All right, so let's take a look at the second problem. So our second problem that we have is a little bit backwards. This problem here, we actually have some information where we want to write the equation. Write the equation of the parabola with the lattice rectum endpoints at -310 and 1510. Then also, and p is greater than 0. All right, so the first thing I would suggest is just kind of getting a mapping of what this looks like. Like, what is this really talking about? So I'm going to start with my x-axis. Actually, I'm not going to even do an x-axis, y-axis nicely. I'm just going to go like that, right? So just random x-axis, y-axis, and then graphing -310, -310, so roughly there, and then 1510 over 15 up 10, roughly there. So my graph is going to have that. We have LR and LR, so our lattice rectum points are there. And then the next thing I want to do is figure out what does that mean. Now remember, if the lattice rectum are left to right like that, that means our parabola cannot open left to right. Our parabola must open up or down. It'll open up if p is positive, and it'll open down if p is negative. Now since it tells us p is positive, we know that our graph is going to be opening upwards like that. So some things that we're going to want to find to write the equation, we definitely need to figure out what is this guy right here. All right, so that's going to be our goal, is figuring out what this guy is. Some other things I know that the focus is going to be right here, and I know that my directrix is going to be somewhere down there. All right, so first thing I notice is that I can find the focus. Okay, so I can find the focus. I can also talk about what p is. So I know that the lattice rectum is 4p, the length of it. So if I figure out how far these two points are from each other, this will give me my p. So I look at these guys right here, and it looks like our lattice rectum has a total length of 18. So the lattice rectum, I don't want to say the points, but the lattice rectum is equal to 18, the length of it. And in the last problem, we noticed that the lattice rectum length was 2p this way and 2p this way for a grand total of 4p. So we could say that the lattice rectum, the 18, must equal 4p. So we have 4p is equal to 18. We simplify this, we solve this, we get p is equal to 9 over 2, or if you wanted to, if decimals are what you prefer, 4.5. Either one's fine, it really doesn't matter. I'm more likely to use fractions in class, so I'll probably continue using the fractions on this guy here. All right, so we now know that p is 9 over 2. The next thing we can do is we can figure out where is our vertex. Well, actually, we probably should figure out where our focus is. Since this is where our focus is, what we could do is we could find the midpoint of this guy right here, of these two lattice rectum points. So remember, the focus is the midpoint of the lattice rectum. So we're going to say -3 plus 15 is 12, divided by 2 is 6. So 6 comma 10. So this point right here is going to be 6 comma 10. So our focus is at 6 comma 10. Notice, once again, what am I trying to do? I'm trying to write the equation of the parabola, and right now I have pretty much only the p portion of it. I now need to find my h comma k, which means I need to find the vertex. So now I have to I take my focus and I think about, okay, so how far is the focus to the vertex? And if you remember, the focus to the vertex is p spaces. So the focus to the vertex is p spaces away. So from my focus, I need to go down till I hit my vertex. So my vertex is going to be 4.5 spaces below the focus. So to make it drop below it, I have to subtract from the 10. So this is going to give me 6 comma 5.5, or 6 comma 11 over 2. All right, so now that I have my focus, I actually have my h comma k. So my h is this guy, my k is this guy, and my p is this guy. Now comes for a little bit of thinking. We have to figure out, are we talking about the equation where x is being squared, or are we talking about the equation where y is being squared? Now since it's the one that looks like a function, I would say this is the one where x is being squared. So I'm going to write out the basic structure of that equation, and it's x minus h squared is equal to 4p times y minus k. And then now I just plug in all the information that I have. So I can say x minus 6 squared is equal to, now remember 4p is 18, so I can just put 18 times the quantity y minus 11 over 2. And this right here is our last problem. There is going to be one more video to talk about completing the square. So when you have parabolas that are not in standard form, where you have to modify it to get it into standard form. But other than that, this should be able to take you through the majority of the homework. If you have any questions, please hit me up. And thanks for watching.